In a momentous event on September 26, 2023, scientists at NASA's Johnson Space Center unveiled the contents of a space capsule containing the largest asteroid sample ever collected. This sample, retrieved from the potentially hazardous asteroid Bennu, offers a rare glimpse into the early solar system's history. However, upon opening the sample return canister from the OSIRIS-REx mission, researchers were met with an unexpected sight: a layer of black dust and debris on the avionics deck, along with a sample weighing 100 grams more than expected. This raises questions about the sample's integrity during its journey back to Earth. What caused this phenomenon? And what implications does it hold for scientific analysis? Moreover, what groundbreaking discoveries do scientists anticipate from the detailed examination of this historic asteroid sample? The OSIRIS-REx mission. Launched on September 8, 2016, the OSIRIS-REx mission aimed to achieve three primary objectives. Firstly, it sought to collect pristine samples from Bennu's surface, providing invaluable material for scientific study of primitive asteroids. Secondly, the mission aimed to characterize Bennu's geology, surface composition, and potential as a resource for future space exploration. Lastly, the mission was crucial for Earth's impact hazard assessment, as Bennu poses a potential threat due to its close flyby of Earth in 2135. The complex interplay of gravitational forces and non-gravitational effects, such as the Yarkovsky effect, could alter Bennu's trajectory, making accurate predictions challenging. Understanding these dynamics is essential for assessing the asteroid's impact risk and mitigating potential threats to Earth in the future. The journey to Bennu aboard the OSIRIS-REx spacecraft was a remarkable endeavor spanning 2 years and 4 months. Upon its arrival at Bennu on December 3, 2018, after traversing approximately 1.4 billion miles, or 2.2 billion kilometers, the spacecraft entered orbit around the asteroid. This marked the beginning of a series of surveys and mapping activities aimed at identifying the optimal site for sample collection. The most thrilling phase of the mission occurred on October 20, 2020, when the spacecraft executed its sample collection event. Utilizing its touch-and-go sample acquisition mechanism, TAGSAM, the spacecraft briefly made contact with the asteroid's surface to gather material. TAGSAM, a robotic arm attached to the spacecraft's main body, delicately collected the sample in the microgravity environment of Bennu. Operating within extremely tight constraints, OSIRIS-REx had just one opportunity to collect the sample, with no room for error. When the spacecraft made contact with Bennu at the Nightingale site, a burst of nitrogen gas was deployed to agitate and lift surface material into the sample collection chamber. The mission aimed to collect a minimum of 60 grams of material. However, to NASA's delight, OSIRIS-REx exceeded expectations by gathering 300 grams of sample material during the brief 9-second contact with Bennu, 5 times more than anticipated. Despite this success, an issue arose when some of the material began escaping due to a jammed flap caused by larger rocks. To prevent further loss, NASA opted to forego the scheduled measurement of the sample and sealed it for return. Departing Bennu on May 10, 2021, OSIRIS-REx commenced its journey back to Earth. After nearly 2.5 years, on September 24, 2023, the spacecraft reached Earth's vicinity and released the capsule containing the precious asteroid sample. The capsule re-entered Earth's atmosphere at a staggering speed of 12 kilometers per second before deploying a parachute to facilitate a safe descent. Ultimately, the capsule landed intact at the Utah Test and Training Range, where it was recovered by NASA personnel. A few days later, scientists at NASA's Johnson Space Center in Houston eagerly opened the lid on the sample return canister, unveiling a sight that both surprised and excited them, setting the stage for further analysis and exploration of the asteroid sample's contents. Upon opening the sample return canister from the OSIRIS-REx mission, scientists were met with a surprising sight: a layer of dark powder and sand-sized particles coating the avionics deck. This dust, believed to have originated from Bennu itself, not only lined the interior of the canister, but also extended to its exterior surfaces, including the avionics deck housing the spacecraft's electronics. The presence of this dust posed a significant question: how did it enter the canister in the first place? According to NASA, OSIRIS-REx's touchdown on Bennu likely generated a shockwave that propagated across the asteroid's surface, causing certain materials to be expelled into space. Some of these materials trailed behind the spacecraft as it departed from Bennu. eventually adhering to its outer surfaces. Additionally, a portion of the expelled material entered the sample canister through the open flap, mixing with the material collected by TAGSAM. Despite the unexpected presence of dust and debris, the combined mass of the sample, including the additional material, exceeded the mission's scientific requirements, totaling approximately 400 grams. Furthermore, the sample remained in excellent condition throughout the return journey, with minimal exposure to high temperatures or contamination. However, the presence of dust and debris on the avionics deck presented a unique challenge for scientists. Specialized tools and techniques were required to carefully remove the particles without causing damage to the sensitive electronics or risking the loss of any sample material. Additionally, scientists undertook meticulous documentation and cataloging of each fragment of dust and debris, recognizing their importance as integral components of the sample inventory. Despite the challenges encountered, this sample return mission marked a historic achievement in space exploration. Asteroids like Bennu serve as invaluable time capsules, preserving a record of the early solar system's composition and evolution. By studying asteroid samples, scientists gain insights into the origins of our solar system and the potential for life beyond Earth. The significance of asteroid exploration extends beyond scientific curiosity. The OSIRIS-REx mission, now renamed OSIRIS-APEX, will shift its focus to studying Apophis, a near-Earth asteroid with a close approach anticipated in 2029. OSIRIS-APEX aims to gather crucial data to better understand the composition and behavior of near-Earth objects, ultimately aiding efforts to mitigate the threat of asteroid impacts on Earth. What do you think about this? Leave it here in the comments and take the opportunity to like the video and subscribe to the channel for more videos like this.